Good evening, everybody. My name is Ranjitha, and I want you to meet Steph. Steph is a small farmer in New England who has a plot of about 20 acres. As you can see here, she's currently harvesting spinach off the ground with a pair of scissors. Now, Steph's farm is one of approximately 10,000 family-owned farms in the Northeast, many of which are much too small to afford the large-scale industrial harvesting mechanism used on other farms to harvest other leafy greens like arugula, mustard greens, and other kinds of spinach and lettuce. Now, as you can see, this hand-cutting mechanism, this scissors process to cut spinach is tedious. It's difficult, it takes a lot of effort, it's time-consuming, and all in all, it's very inefficient. Now, Tyson Newkirch, our farm contact at the farm school in Athol, Massachusetts, speaks about this issue. Farming can be backbreaking work as it is. Any opportunity you have to minimize or eliminate the form of repetitive stress is going to make workers healthier and happier. Namely, this spinach marketing for low-level, small-scale harvesting is wide open, and there's a clear-cut opportunity for a solution. And our product, Sprouticus, provides this solution. Now, let's see Steph demonstrate Sprouticus. So, first of all, Sprouticus is powered by a gas generator. Unfortunately, due to the regulations in Kresge Auditorium, we can't run the gas generator. However, we're still going to demonstrate the device for you through an AC converter. So now, as you can see, in Steph's farm, she'd switch on the generator, move through the front of the device, and then engage the device by toggling a switch at the front of the device in order to start up the cutting and collecting mechanisms within the harvester. However, for security purposes, none of the mechanisms within the harvester will be operational until Steph squeezes the handlebars to begin her harvesting procedure. Now, as Steph squeezes the handlebars and decides to harvest, she can slowly walk across along the spinach bed, collecting spinach as she moves along. Now, Steph will demonstrate this device for you. Steph and Fariha will demand.
Theoretically, of course.
It should be connected to a wall outlet. But anyway, so theoretically, Steph would push the device along the spinach bed, and you would see all that system in the back would turn on through the generator power, which the farmer would supply, moving the device along the bed, collecting and harvesting spinach as it moves along. When Steph's collection bins, which are in the sides of the device, are filled, she can simply take them out, empty them into other bins, and replace them on the device, which she'll do right now to show you. Empty the spinach bins, and then put them back and keep going down the row. Because the blade width on our device is half the width of a spinach bed or leafy greens bed, she'd make one pass down the bed, turn around, and cut in the other direction, finishing her cut. I'll turn it over to Fariha now for more details.
Thank you. I'd like to go briefly through how the device, of course, is designed to work on improving productivity and comfort, adding functionality, and maintaining quality. When designing Sprouticus, we considered 3 key design areas. The first was the user interface, the second was our cutter carriage, and the third was our collection system. The user interface, of course, is first. We had a lightweight frame that was designed to greatly improve the leafy green harvesting process. The frame contains 2 symmetrical handlebars with multiple grip configurations to allow for ease of use between 1 or 2 users. The handlebars were located at the proper height and length along the device to allow our range of users to easily take a stride, push the device, and cut along the bed, while still seeing the cutting blade to make sure everything's looking okay. Lastly, the generator on the back can easily be removed, allowing the farmer to pivot the device on its back and sit in a pickup truck for easily transporting to the fields. Sprouticus is powered fully by a gas-powered generator, which the farmers will supply themselves. Once the generator's been engaged, the user can simply come to the front, toggle the switches, engaging all of the systems. After they've been toggled, all the user has to do is grip the handlebars, turning on the blowers and the blades. This system is also a safety feature because they will kill power the minute the handlebars are not connected. The second design area we looked at was our cutting carriage. Spartacus was designed for use in farms. Though there's a reasonable degree of standardization within farms in the Northeast, there's still a range of variables due to different farm equipment and different plant type. We've created a blade carriage system that begins to address some of these problems. The blade is a reciprocating blade powered by a half-horsepower motor. It rests on this carriage, which is mounted onto the frame by 2 brackets and 2 springs. The first variable that we have addressed is different planting density on farms. As you can see, farmers can go between having just 3 rows planted to planting continuously across the row. In order to address this, we've created the sliders that connect to the main frame, allowing the user to slide the blade across the width of the bed in order to avoid cutting in the middle of a row. These sliders also help deal with the second degree of variability. Farmers range between having flat beds and beds raised at 6 inches. Our sliders allow the device to move up and down and passively adjust for this change in height. Cutting by hand is a tedious process, but it allows farmers to maintain a high level of control on the quality. In order to compensate for this, the sliders also allow the blade to maintain its level, regardless of the terrain that the wheels may be going over. Lastly, because different plants need to be cut at different heights up the stem in a range of about 2 inches, we've added brackets that allow farmers to change this height depending on which plant they're currently harvesting. In order to have a complete harvesting system, we also needed a collection mechanism. The key challenge with this situation was being able to maintain the almost 100% level of collection that was achievable in harvesting by hand. In order to compensate for this, we created a system that was a combination of blower and vacuum to collect a large degree of the leaves. The key blowing mechanism was a manifold located at the front. The blowing air lifted the leaves, opening up the stem to the blade. Moreover, the blowing allowed the leaves to fall into the chute, where they were then picked up by the vacuum and deposited into the bins, ready to be washed and sold. In the future, we hope to include a power drive assist to offset the weight of the device, as well as to deal with torque problems caused by having only one user. We also hope to standardize the connection between the bins and the vacuum in order to allow farmers to use the bins they currently have. And finally, we intend to sell this product in a range of variable widths to compensate for having different widths of farms across New England. Now here's Eduardo with business.
Thank you, Fariha. We believe Spartacus is not only an essential tool, but also has the potential to be a great business. Our closest competitor comes in at $12,000 after shipping cost, and this is simply too capital intensive for most of the vegetable small and medium-sized farms. Spartacus is targeting this sector of family-owned vegetable farms in the US. Currently, there are about 12,000 vegetable farms in the Northeast alone, of which 10,000 are individual family-owned farms. We have calculated the production cost of Spartacus at $500 and plan on selling it directly to farmers at a price of $2,000. We plan on breaking even with 300 units at the end of year 2. Assuming a 10% market penetration, we have calculated an internal rate of return of 41% at the end of year 5, assuming an initial investment of $650,000. Furthermore, there is also potential to expand into the growing crop services industry, as well as into international markets. We'd like to thank our mentors, our lab instructors, the 2009 staff, and our farm contacts who have made Spartacus a possibility. We'd also like to thank the small and medium-sized vegetable farms of New England, who with Sprouticus can improve productivity, add functionality, and maintain quality.
Hey, thank you, Yellow Team. So I'd like to point out that the house power got tripped when they started their project. So it's not necessarily has to do with their machine. And so we've just wired it up again to see if we can do another demo. Are you guys ready?
Yeah.
Okay. Fabulous.